Hi guys, good morning. So in the last session we saw about BGP. Okay, so we saw about BGP, then we saw about getting back to BGP attributes that we have 12 attributes which are next stop reachability, weight, local preference, local injected routes, then mixed AS path, origin, MED, neighbor type. Okay, then IGP known metric called as BGP route, least neighbor ID. Okay, or you can say least neighbor router ID, and then you can say least neighbor interface ID. Okay, so these are the BGP attributes. Then we know that BGP works on port number, TCP port number 179. And then we had introduction to the AS numbers. So we know that AS number earlier there were 2 bytes, that means ranging from 0 to 65535. And then they were extended because of exhaustion to 4 bytes. Okay, and now we have around 4.3 billion unique AS numbers, right? And out of these ranges, these are two ranges like from 64512 to 65535, which are reserved for private ASNs in the 16-bit range, and then this range is reserved in the 32-bit range for private ASNs. Okay. Then we talk about reservations like 0 and 65535 are reserved, then 1 to 64495. This is assignable by INA for public use. Okay. Then we saw about, like 64496 to 64511, these are for documentation, and remaining are there which are for private use. Then we saw the differences between your IGP protocols and BGP. So if you talk about the differences, you know that your IGP protocols, they use multicast packets, okay, to discover the neighbors, and the neighbors should be connected on the common primary subnet. But here the neighbors are explicitly configured. They do not automatically discover the neighbors. Okay, in BGP, neighbors are not automatically discovered. We have to configure using the neighbor command, right? And it's not mandatory to be present on the same primary subnet. Then the other protocols, they do not use TCP, while BGP uses TCP port number 179. And the other protocols, they advertise prefix length, and here it is known as NLRI, which is network layer stability information. And if you talk about your OSPF area, your IGP protocols, so they advertise metric information, while BGP advertises path attributes. And the other protocols, they focus on fast convergence, while BGP focuses on scalability. Okay, BGP focuses on scalability. Okay, and BGP is a highly scalable protocol. It can handle large number of routes, which is not possible with the IGP protocols. Then after we saw about BGP message types, that we have 4 messages. We have open, keep alive, update, and notification. So your open messages, they are used to establish a neighbor relationship. Okay, and keep alive messages, these are used to maintain that neighborship. Okay. Then update messages, these are used to exchange the path attribute informations. Okay, or you can say the route informations. And then we have the notification. So the notification message is used to indicate an error in case of BGP. Okay, so if we talk about the keep alive, so default keep alive time is 60 seconds and the whole time is 180 seconds. After the messages, we saw about the neighborship states, that we have 7 neighborship states, which is idle, connect, active, open, sent, open, confirm. Sorry, not 7, 6. Okay, established. So these are the 6 neighborship states. So idle means there is the neighborship is administratively down. Okay, that means neighborship has not been established yet. You have configured the neighbor, but the neighborship has not been established. Okay, then connect is there, where the TCP 3-way handshake process will start. That means BGP peer will try to establish a TCP 3-way handshake, and if the 3-way handshake is completed, then it will go to open send state. And if the 3-way handshake has a problem, okay, that means due to any reason, maybe the port number 179 is blocked. Okay, that is not allowed, or ACLs are breaking the rule, or there is a routing issue. So in those kind of scenarios, it can go to the active state. So in the active state, it will try to establish 3-way handshake once again. If the 3-way handshake is successful, it will go to open send. If the 3-way handshake is not successful, it might go to connect or idle. Okay. Then after, if the 3-way handshake is successful, it will go on the open send state, where the open message has been sent to the neighbor. Okay. And now it's waiting for the open message from the neighbor. So if the neighbor is sending open message, it will go to open confirm. If the neighbor is not sending open message, instead it is sending some sort of notification, then what will happen? It will go back to idle. Okay, let's say open message has been received. So open confirm state is there. In the open confirm state, it will either wait for a keep alive or a notification. If a keep alive is received, it will go to established. If a notification is received, it will go back to idle. Okay. So then once the keep alive has been received, the state will be established. And there are two parameters that will be verified in the open messages. So what are those parameters? Those parameters are the BGP versions must match, the source IP address of the neighbor, that means whatever the open message neighbor has sent, that IP address should match with the neighbor that I have configured in my configuration. Same way, ASN number should match. Then they should have unique router IDs, and if you have configured any security parameters like passwords or TTL, they must be set appropriately. So these are the parameters that will be checked. Then we saw about BGP flavors, which is we have two flavors, IBGP and EBGP. IBGP is responsible for providing communication within an AS, while EBGP is responsible for providing communication between different AS. And then we saw about the configurations of IBGP and EBGP. Okay, so configuration wise, command wise, everything is similar. Okay. Now, today we have to see about the loop prevention mechanisms. So what is the loop prevention mechanism in case of IBGP? If we talk about IBGP, right? So in case of IBGP, the loop prevention mechanism that we have is known as IBGP split horizon. Okay, so let's understand what is IBGP split horizon, and then we will go for the EBGP loop prevention mechanism. Okay. So first of all, IBGP loop prevention mechanism. So the IBGP loop prevention mechanism is IBGP split horizon. Okay. This is the loop prevention mechanism. Now, what is IBGP split horizon? So, according to IBGP split horizon, okay, what is going to happen? According to IBGP horizon, then basically receives a BGP route from the IBGP will not advertise that route to another IBGP. Okay. Now, what does it mean? So, understand this thing with an example. Let's take three doses. R1, R2, R3. They are connected. This R1, R2. This is R. So now consider like they are in the single relation, same relation, and let's say they have to cut something like this. So let's say this side we have a look at Panama number phase and this side we have the plan. Okay. Okay, these are the lookouts. Now, if they're in the same year, and let's say they belong to the same optimum system, call it ASM 150. So that means all our IPTP fields. Okay, now what we have that when R1 will advertise this route to R2, the one, it will advertise 1.1.1/W. Okay, so R2 is receiving, but see, R2 has received this 1.1.1.1 information from an IPGP peer because this is an IPGP peer. Okay, so R2 is not going to advertise the same thing to R3. This will not happen. This is what the IPGP split horizon is. That if I have received a route from IPGP here, I will not advertise that route to another IPGP peer. And same thing will happen in the case of trade-off. That if R3 is sending the information about trade-off, okay. If this is the information shared by R3 to R2, R2 will receive it, but R2 is not going to advertise the same information. Okay, R2 is not going to advertise the same information to R1 due to IPGP split horizon. Okay, this is R1. This is the IPGP split horizon. Now here you can understand one problem is there. What is the problem? If the R3 and R2 they will not get these routes. Okay, let's say R1 will not receive the route for trade-off 3 and R3 will not receive the route for 1.1. They will not be able to communicate. So we want communication, right? R1 to communicate with trade-off 3 and R3 to communicate with 1.1. So what we will have to do? We will have to break this IPGP split horizon. Okay. So if I say that due to IPGP split horizon, R1 will not be able to communicate with trade-off and R3 will not be able to communicate with okay. So the communication we will have to do the IPGP place over. Okay. So to break the IPGP split horizon, we have to configure. Okay, we have to configure something called as full mesh. And full mesh means a neighborship between R1 and R2. Okay, we have to configure a neighborship between R1 and R2. So we have to configure a direct neighborship. But for this neighborship, we will need region repeat. Okay. So inform and negotiate between R1 and R2. We need reachability between R1 and R2. And for reachability, you can use static route or a dynamic route. Anything you can use. This is clear. So what we do, we are going to provide something either a static route on R1 for R3 and on R3 for R1, or else we can use OSPF area to this kind of dynamic route performance. This is clear in doubt to first. Yes, sir. Let's clear it.
Yes, sir.
Okay. So now let's see this in category. Is it okay now? How is it now?
Sorry, sir.
Is the voice okay? All right. So let's see. IBGP, loop prevention mechanism. This is the lab. So let's wipe all the notes and start all of them. Okay. And meanwhile, these are coming up. What we can do is download. Let's configure it. Arrow, neighbor, configure terminal, line control view, layout synchronous, and we'll say host name, R1, the base, it will be IP address, IP address, then have 192.168, 0, data, interface loop and one, IP address, 1.1.1.1. Loop prevention is what? How do you avoid the loops? Okay, you don't want any sort of loop. That is the okay. And let's also configure the BGP. So router BGP 123 because the ASN number we are using here is 123. Then we will say neighbor and neighbor will be sorry 192.168. Remote is and same is 123 network 1.1.1.1 mask 12.0 mask. This is the R1 configuration. Then R2 postman will be R2 3050 will be 12.2 3051 will be 23.2. Then out of BGP 123, maker will be 12.2, remote AS 123. This is okay. And one neighbor will be like one neighbor is 12.1 and another will be 20.3. And here this will be 192.168. This will be 0. Then the R2 configuration with a similar configuration they have for R3 as well. R3 first name is R3. This will be 23.3. And this is going to be without. Neighbor will be 23 dot two. This will be without two. And neighbor will be 23 dot zero. These are the configurations. Let's take access of the devices. R1. R1. R2. R3. So first of all, let's paste the configuration in R1. R1 done. R2. R3 interface is in 0 by 1. So this is something like 0 by 1. Copy. Now we should see that we have the BGP neighborships up. Okay, so I can see here the neighborship is up, and on R2 also two neighborships are up. R1 also is neighbor with the R2. Okay, now if I go and take a look, right, on R1, if I say to IP, so I can see I have a route for 1.1, I have a route for 12.0, but there is no route for 3.0. Okay, and here if you see star, that means it's a valid route. Okay, and in some time it will select the best route. That means it will show star and the greater than symbol. But here it will not show. Why? Because these are the connected routes. So if you see these two IP route, so you will see these routes will be preferred rather than the BGP routes. Okay. And in some time, you will see, like right now, I'm not having the 3.3 information. Why? Because R2 is not advertising here. Same way on R3, I don't have information about it. Like if I say this to IP route, so I don't have information about 1.1 here. Okay. But if I go and check on R2, do you show IP? R2 has the information. R2 has this information about 1.1 also, about 3.3 also. But R2 is not sharing it with anybody else. And you can see star means valid route, greater than symbol best route, and I means this is a internal BGP route. This is an internal BGP route, and also you can verify like this. Sorry, so if the AD value is 200, that is IBGP. If the AD value is 20, that means it is EBGP. So right now we are having IBGP routes. Okay. Now This because of IBGP split horizon, we are not having the communication from R1 to 3.3 because there is no route itself. Okay. So what we have to do, we have to make an R1 neighbor with the R3. Okay. So right now, if I try to configure the neighborship, if I check on R1, do show IPBGP neighbor. Sorry, IPBGP summary. So I can see it is only neighbor with what? Only neighbor with 12.2. I don't have any neighborship with 23.3. So if I go and configure in the BGP, if I say right for BGP 1 to 3, and if I say neighbor ID is 192.150.1.3, and remove base 1 2. Okay, and let's say on R3 I will go and configure router BGP 1 to 3, and I'll say neighbor 192.168.1, remote is 1 to 3. So this is not going to form a neighborship. Okay. This information is there. Well, zero information is there. Because on the R3 we advertise. Okay, just give me 1 second. I'll remove these two because we will not advertise these methods. See, here we have used BGP, so anyhow the connectivity must be there. Okay, like I said, you can use dynamic routing protocol or you can use a static route also. So since I use dynamic routing protocol, right now the neighborship came up. We used IBGP itself for communication. Okay, but if you do not use IBGP or a dynamic routing protocol, then you will have to use a static route. Okay, for reachability. So right now you can see now once they have become neighbors, so overall ideally your R1 has to become neighbor with R3. You can see in the definition what we said that if you want to break the IBGP neighborship or IBGP split horizon, see here, to break the IBGP split horizon, we have to configure a full mesh. That means a neighborship between R1 and R3. And for this, we just need a reachability between R1 and R3. So right now the reachability was provided by IBGP itself because we advertise the routes everywhere. Okay. So now if you check, you show IP, BGP. So now you see I have a route for 3.3 also. I have a route for 3.3 also. So since I have a route for 3.3, if I check to show IP route, okay, still it is not selected as a best route. It will take some time. Like if you say which IP BGP. Still wait for it. The information already came on, but it's not selected as a best route. So wait for it. And if it takes time, what you can do, clear IP BGP we'll just clear the BGP process, same like we clear the OSPF process. Same. Still not selected. And if okay, this one. This site. But here also see 1.1 is not getting selected as the best one. So let me do one thing. I'll just go and remove this directly connected link one advertisements. Okay. P. Now let's see. Who show ITV? Clear ITV start. Let's clear the BGP process. Here also clear ITV start. Okay. So now all the neighborships are removed, and now they will reestablish the neighborship. Okay, you can see R2 became neighbors. Now, see here. You show IP BGP with college. No route information is there, and if I check summary, you can see this state is idle, so after some time it will be removed. Okay. This neighborship will be removed, but only one full neighborship is there. Okay, that is with the 12 and you can see we are not having any information. So I have information about 1.1, but I don't have any information about 3.3 here. Even though if you look at my configuration, if I say do to section, so I have configured 23.3 also as a neighbor. Even though I have configured 23.3 as a neighbor, still I don't have it. If the neighborship state is what? Idle only. Why? Because no reachability is there. And for reachability, what we have to configure static out. Like if I configure static out, if I say IP out, and let's say I want to reach 192.168, and exit interface will be 0 by 0, and not stop will be 12 dot 0. So, and same thing if I configure here, that IP out, I want to reach 12.0. Interface is 0 and next is now reachability is there. So what will happen? The neighborship is with the 12.1 came up, and once the neighborship came up, if I say do show IPv, now I will have 3.3 information also, and see this time it has been selected as a best route. And if I say do show IP route BGP, so you can see my BGP route is there, and from here if I try to pick do pick so I have the communication. So what will be my configuration of BGP here? See, we don't need these comments. These comments are not required. Now understand what is the BGP configuration. We configured BGP, but due to this IBGP split horizon, the 3.3 was not coming. So what I did on this, I configured one more neighbor. Okay, so much neighbor. So my neighbor and my neighbor is 101. This configuration is 1 R1. And I said remote is 1. And same thing I did on here about neighbor 12.1. That my neighbor 12.1 is there. But for finding this neighborhood, what we need a route. on R3 also as well as R1 also. So what we use, we use the static route. So we said IP route, and from R1 I need to reach the exit of the exit interface will raise the initial value. My next interface. Well, okay, this is recommended. And same thing. One route I configure on RP as well. Okay, one route I configure on RP as well. This is the configuration. Okay. This is how you avoid loops in the IBGP with the help of IBGP loop prevention. And if IBGP loop prevention is creating problem, so in that case, we can break the IBGP split horizon. Okay. Now, if we talk about eBGP, right? Now, here one more thing is there. Sometimes you might say that what if I use a default route here? If you use a default route, you will get the connectivity, but the neighborship will not come. If you give a default route in place of static route, let's say you might say that what if I give a default route on R1 towards this side and on R3 towards this side? So yes, you will get a connectivity from R1 to R3, but the neighborship, the BGP neighborship will not come up. Why? Because BGP neighborship will require specific route. Okay, there must be a specific route. Default route is not going to work. So that thing also you can note down here that we cannot use a default route for breaking the or for providing stability, or you can say for breaking the IPv6 device. The default route will provide reachability. The neighborship between R1 and R3 will not come. Yes, okay, you either have to use a static route or OSPF AGRP protocols. This is clear. All right. Now next is what about eBGP. eBGP loops prevention. So if you talk about eBGP, right? So according to eBGP, what will happen? eBGP uses AS-PAR. Okay. eBGP uses least AS-PAR to avoid loops. Okay. What does it mean? It simply means eBGP router will always use the least AS-PAR to reach the destination. This is the first thing. Second thing, eBGP router will draw a BGP advertisement. Like what kind of noise it is? What kind of noise?
In between your voice, so we are getting some noise, sir. Like I'm unable to explain that.
So let me change the headphone. Let's see if that works. Might be the keyboard ones if there is clicking sounds.
No, it's not keyboard. So
Just a minute. Let me complete this statement. So eBGP router will drop BGP advertisement. Okay. When it sees its own AS number in AS path. Okay. Now let me change. Let's see if that works. Audible now?
Yes, sir.
Yes, sir.
yeah, yeah, no, it's better.
Okay. So like eBGP loop prevention mechanism. So here what will happen that the eBGP router will always choose the least AS path. That means it will choose a path where it has to travel the less number of autonomous systems. And second thing, let's say if a router receives an advertisement, so in that advertisement, it will check the AS path attribute. And in the AS path attribute, if it sees that, okay, it contains my own AS number, then it will consider that, okay, it has already passed through my ASN and now it's coming back to me. So that is a possible loop. Okay. So that is the reason that it will drop it to avoid the loops. Okay. Now, let's take an example for this. Okay. We'll understand this thing through the lab only. So let's go to the lab and close this one and stop all these nodes. Close it. Now we are considering this scenario here. Let me wipe all the notes and start all the notes. Okay. Now, what we are considering, let's say this is R1 and we are having ASN number 1, 2, 3, and 4. Okay. So if we talk about, let's say, R2, so R2 can get the, advertisement from two sides. R2 can get the advertisement from two sides. One is directly through R1. This is one way. And another way is that it will go through here to here to here like this. This is another possibility, right? So when it will check this route, it will see that, okay, it has it has traversed only AS number 1. Okay, it is coming from directly AS number 1. But when it will see this path, so it will see AS number 1, 3, and 4. So here the AS path attribute will contain 1, 3, and 4. Three informations will be there. So it will select, R2 will select the least AS path. That means which route is having the least number of AS path. That route I will select. So obviously it will select the route that is directly coming from the R1. This is the first statement, that it will select the least AS path. Second case, what is the second case? That let's say if we talk about R4, okay, let's say if we talk about R4, then what will happen? Or let's say you talk about R1. So if R2 is going to advertise it to R4, then R4 is going to advertise it to R3, and R3 is going to advertise, like the second case, if I try to explain. So let's say that R1 advertised this information to R2, then R2 advertised this information here, R3 and R4 advertised here, and R3 advertised here. So when this will come, so see, R2 will advertise it at that, okay, AS number 1 and 2. Then here this guy will advertise 1, 2, 4. And when R3 will advertise back to R2, 1, 2, 4, 3. So when this message will reach back to R1, R1 will see that, okay, in the AS path attribute, it contains my information. My AS number is there. That means this packet, this routing update has already arrived from, or already traveled from my ASN. So that means R1 is going to drop this update. Okay. So this is how they will avoid the loops. Now, there is one more scenario here. If you understand that, what if we talk about R4? Because if I check on R4, first of all, so from here, number of ASNs that will be there in the update will be 2, ASN number 1 and 2. And from this side, again 2, that is 1 and 3. So both are having the same number of AS path. Then how the R4 will select the best path? Okay. So what R4 will do, it will say first come, first serve. That means whatever the route reach me first, I will select that route. It will check for oldest eBGP route. This is where, the attribute, right? We have one attribute in the BGP. We have a attribute, right? That it will check for what? It will check for oldest eBGP route. If everything is same, neighbor type is same, and all these things are also same, AS path is also same. Okay, if everything is same, then it will check for oldest eBGP route. Okay. So that means whatever the route will be learned first, that route it will select as a best route. Okay. Now let's see this thing. Okay. So let's go here, R1 configuration. 12.1, one interface is configured. Then Z0 by 1, we will configure with 13.1. This is 13.1. Then R2, we have Z0 by 0, 12.2. Z0 by 1, which is 24.2. Okay, Z0 by 1 was already there. Okay, but we have a loopback here. So let me copy this. Which is 2.2.2.2. Okay. And if we talk about the network, so here the neighbors. So one neighbor is 12.2 and another neighbor is 13.3. Okay, this is the neighbor 13.3. Okay, on R2 we don't have a loopback, so we don't need this. And the ASN number here is on R1, it is 1. For 12.2, ASN number is 2. And for 13.3, ASN number is 3. This is okay. Then R2 configuration. So R2 is 12.2, 24.2. ASN number here is 2. And neighbor is 12.1 and 24.4. So 12.1 neighbor, ASN number 1. And 24.4, ASN number 4. Then R3. So 13.3 and 34.3. This is 13.3. Okay, this one is Z0 by 1. 34.3. Loopback we don't have. So there is no loopback. Static route we don't require. So this is R3, ASN number 3. 23.2 is not there. This is 34.4. And ASN number is 4. And 13.1, ASN number 1. And this route we don't require. Okay, and here also we don't need this static route. Okay, now only R4 configuration is pending. So let's copy this R3 configuration. And this is R4, R4, Z0 by 0 is 34.4. Z0 by 1 is 24.4. So router BGP 4, 34.3 is one neighbor and 24.3 is another neighbor. Not 3, but 2. This is 3, this is 2. And this is the ASN number 2. Okay, so this is all the configuration we have. Now let's take access of the devices. R1. And then we have R2. R3, R4. Okay. R2, R3, R4. Copy R1 configuration. R2 configuration. R3 configuration.
Sir,
This is,
sir,
yes.
R4 neighbor 24.2.
Sorry.
Sir, R4 second neighbor 192.1.
Come again.
Router 4, sir. Neighbor 24.2.
Oh, yes, yes. 24.2.
Also
Thank
the
you.
remote is.
Correct.
Also the remote is.
Your voice is low.
Okay, sir.
Please come again.
That's only, sir. That's only, sir.
Okay. Thank you. Copy. Okay, done. So now we will see about the neighborship. Almost everybody should have two neighborships. Okay, peer in wrong, yes. 34.3. Oh, yes, this will be in the, yeah, right. All right. Now we should have the neighborship. Yeah. So everywhere we should see almost two neighborships. So do show IP BGP summary. Here I have two and nobody's in the idle state. Do show IP BGP summary. Here also everything is good. Do show IP BGP summary. Everything is okay. Do show IP BGP summary. Yeah, everything is good. Now let's check it, right? On R2, we can have two routes or two possible ways from, one is directly from R1 and another one is through the, another one is through this 1, 3, and 4, right? So let's check on R2. If I say do show IP BGP, so you see for 1.1, I'm choosing which path? I'm choosing 12.1 as a next hop. Okay. And if we talk about R4, so R4 will select, the path that has been received first. So right now we saw that there was a problem with the neighborship from R3. So that means definitely it will select the path that is coming from R2. Okay. So let's see here. Do show IP BGP. And you can see we have two possibilities, one through the 34.3, another one through the 24.2. But which one is selected as the best route? Both are valid routes. Star, that means valid routes. But which one is selected as a best route? It is the 24.2. Is it clear?
Yes, sir.
So this is how
Yes.
eBGP is going to prevent the loops. Okay, and how it is going to prefer the best routes. Now, see, right now we are trying to make, or right now we have seen that all the neighborships, they are happening through what? They are happening through the interface.
That is 24.2. That is the physical interface. But in eBGP or in BGP, we can form the neighborships using loopback also. We can form the neighborships using loopback also. So let's see how you can form the neighborships using loopback, because an interface can go down, but the like if a physical interface you are using for neighborship, then if the interface goes down, the neighborship will go down, right? But if you are using a loopback interface, we know that the loopback will never go down. Okay, as of now, if you consider, let's say if I'm using 12.1 as a neighbor IP, right? So what will happen if the Z0 by 0 interface is down? Then my R2 neighborship will break with R1. That means R2 will break the neighborship with R1. Why? Because this interface IP is not available. This interface is down. But you see, I have one more path. If I want, I have one more path through R4, R3, R2. I can reach R1. But the problem is what? That this this interface is down. So the neighborship will break. And when this will come up again neighborship will come up. So if you want to prevent these kind of breaking of neighborship, rather than using physical interface, okay? Rather than using physical interface for forming the neighborship, what we can do, we can use the loopback interfaces. So that what will happen, if I don't have connectivity through this interface, at least I will have connectivity to the loopback using the other alternate route. At least my neighborship will never go down. Is it clear? That why we are forming neighborships using loopback?
Yes, sir.
So that our
Yes, sir.
neighborships will not break. So now we will see how you can, form neighborship using loopback in case of IBGP and eBGP. So let's close this and stop all the nodes, close. So first thing, let's talk about IBGP neighborship using loopback. Okay. So understand this thing, that by default, BGP will form neighbor adjacency, okay, using the exit interface IP. By default, it will form the neighborship using the exit interface IP. So if the interface goes down, the neighborship will break. To prevent such breaking of neighborship, we can configure BGP to form neighborships using loopback interface. Okay. Since a loopback interface does not go down, the neighborship will not break as long as there is reachability to the loopback. Okay, you may have alternate paths, right? So that might provide you the reachability. So as long as the reachability is there, the neighborship will not break. Okay. So for if you talk about IBGP, so the command is router BGP and your ASN number. Okay, then what you will say? Neighbor. Then here you will give the neighbor's loopback IP. And then you will say update source. This is one extra comment. Okay, and your loopback interface number. Self loopback interface number. Okay, normally how we configure the neighborship, so that command will also be there. Okay, it's not like you don't have to use this command. This command will still be there, neighbor, and this thing, neighbor loopback IP, remote AS, and the ASN. So because this is IBGP, so that's why the ASN will be the same, but this is how you will do it. So this is one extra command that we have to use, that update source loopback 0.
Sir, that will be neighbor IP or neighbor loopback IP. Sir, the second step.
Yeah, both will be same only. Whatever you will give here, na, that same
Yes,
thing
sir.
will come here.
Yes.
Okay, so since we are forming the neighborships using loopback, so these both will be loopback IPs only. Clear?
Yes, sir. Yes.
Okay. And if we talk about eBGP, okay. Okay, first let me show you the practical for iBGP, then we'll go for eBGP. BGP neighborships using loopback. Open. So first of all, let's talk about iBGP. Let's start all of them. Wipe all the nodes. More actions. Start all the nodes. So configuration wise, R1 and R2 configurations, I think already there. We just don't need this interface here. Loopback is fine. Neighbor will be, since this is the same as, so this one is not required. This is 12. This is 12. Okay, right now I'm forming the default neighborships. And if you want to form it using loopback, in that case, we will say, okay, I'll do one thing. I'll configure the neighborship using direct commands only rather than copy pasting. Or else you can say like here, I will say 2.2.2.2. Okay, this we will say. And along with this, we will use one extra command, that is this. Okay, we will say update source. Update source loopback 0 or whatever the interface number loopback 1 we are using. So loopback 1. Okay, this is how we will form the neighborships. Okay. And again, if you want the reachability, for from 1.1 to 2.2, you can use a static route. You can use a OSPF, EIGRP, those things we can use. Okay. So rather than advertising this now, what I'll do, I'll add a static route. So I'll say IP route. I want to go to 2.2.2.2. Using the interface, my exit interface is Z0 by 0, and this will be 12.2. Okay, so this will be my configuration. And on R2, if we check, right, so R2 configuration, This will be 12.2 Z0 by 1 interface. We don't have, we have a loopback interface instead. So let me copy this. So here this will be 2.2. Okay. And so ASN 12, this here neighbor will be 1.1.1.1. Here also 1.1.1.1. And for reachability, we will need the route. So for reachability route, this route will be for 1.1. Okay. And here next stop address will be 12.1. This is clear, right? The configuration. Let's take an access. So start MobX. R1. This one is R2. Now let's copy paste. Copy. Paste. If you don't give the update source loopback 0 command, right, then it will not form the neighborship using loopback interface. Again, it will use the exit interface only. Okay, so that command is important. The update source command is important. Now you will see when the neighbor will come up. So neighbor is, you see here 1.1.1.1. Here the neighbor is 2.2.2.2. But if I don't say this, right, let's say if I don't say the update source command, so on both the sides, then they will not use their loopback interfaces to form the neighborship. Okay, they are not going to use the loopback interface. If I say do clear IP BGP star, down, reset. Then if I check now, do show IP BGP summary. So you see my neighborship will be in the idle state only because I didn't give the update source command. So that command is important. Okay, we have to say that I want to use my loopback interface. Okay. So say update source loopback 1. Here also we will say the same thing. Okay. So this way the neighborship will come up. This is clear. Now if I check, earlier it was in the idle state. And now it is not in the idle state. And we can ping, do ping 2.2.2.2. And we have a communication. This is clear how you form the neighborship. So one extra command is there, just the update source loopback and loopback number. Clear?
Yes, sir.
Okay. Now let me close this one. And now let's talk about this case, eBGP. Okay. So in eBGP, what happens that, let's say, for example, this time this is eBGP. So let me do one thing. Here BGP configuration will change. Okay. So if I say this is R1, so router BGP1, neighbor IP, and let's say I'll say the update source loopback. Okay. If I say the update source loopback 0 command here, and neighbor will be in the ASN number 2. This is the only difference. Here self ASN is 2 and neighbor ASN is 1. Okay. I'm trying the similar configuration. Okay. So now if I try the similar configuration, let's see what happens. I'll access R1. And then I'll access R2. And let's paste the configurations. Copy, paste, copy, paste. Okay. So what is the case here? If you will see, my neighborship will not come up. Okay. Even though update source is given. If I say do show IP BGP summary, my neighborship is in the idle state. Now, why it is in the idle state? Okay. Why it is in the idle state? So if I say right click, capture Z0 by 0. Okay, so let's take a look at the capture. Remind me later, view, and I don't want to see the packet bytes. Okay. Now, when it will try to establish a neighborship, right? So in eBGP, what happens? In eBGP, the default TTL value, right? The default TTL value is, in case of eBGP, the default TTL value is 1. So what is happening here? That when it is trying to establish a neighborship, okay? So the TTL value is 1 here. As soon as it will come on this router, the TTL value will get to 0. And if the TTL value will get to 0, the router will drop the packet. The router will drop the packet. In case of iBGP, what happens? The default TTL value is 255. Okay, so no problems. But here in eBGP, the default TTL value is 1 only. So that means when it will come to this router will make it -1, which is 0. And if TTL value is 0, that means the packet life is ended, right? So this is why we are not having this neighborship. So in case of eBGP, we need to use one extra comment. We need to use here one extra comment other than update source loopback 0. Okay. So what is the comment? So I need to increase those. Or let me say, instead of iBGP here, let's bring it here. That first one for iBGP. Because this theory is common for everybody. This is the configuration for iBGP. Now, the default TTL value for iBGP is 255. The default TTL value for iBGP is 255. Okay. While if we talk about eBGP, if I use the same things in eBGP, okay, if I use the same concept, oh sorry, if I use the same concept here, and slight change will be there according to eBGP, this will be self ASN and that will be the neighbor ASN. This is the self ASN. Okay. This will be the neighbor ASN. Okay, so if I use this concept here, okay, so guys, one moment, please. Okay, so here what will happen? The default TTL value is 1. Here, the neighborship will not come up. Why? Because the default TTL value for eBGP is 1. Okay, so if the neighbor is beyond 1 hop or 2 hop, in that case, what will happen? The neighborship will not come up. In that case, the neighborship will not come up. So we have to increase the TTL value. What we have to do is we have to increase the TTL value. Okay. So what we can do here, we can use the eBGP multi-hop command. Okay, we can use the eBGP multi-hop command. This is the command we can use. So what will be the command? The extra command that we have to use, that will be neighbor loopback IP. Okay. And we will say eBGP multi-hop. Now, if I use only this much command, that eBGP multi-hop, So what will happen? It will set the default TTL to 255. It will set the TTL to 255. Now, if TTL is 255, there is a possibility of, attacks. There is a possibility of attacks. So here, if you want, you can set the number of hops. Number of hops, that how many hops you want it to travel. By default, it will set 255. Okay, so this one command we have to use extra. So if I go here and on R1 and R2, if I say like neighbor IP, and if I say eBGP multi-hop, so this will by default set it to 255. And here we can set the maximum hop count. Let's say I want it 2 only. And same thing here, I can do it. That eBGP multi-hop, and here I can set it to. Now you see the three-way handshake process is trying to start again. And you see three-way handshake completed. Neighborship will come up. Okay, it says notification. With 2, it is not coming up. Fine. Let's change it to 3. Instead of 2, make it 3. Finish acknowledgement. Okay.
So can you check the remote host for R2?
Remote host for, yeah, 1.1 only, right? AS number is
I mean remote AS.
R2. Yeah, this is 2 only. Here 1 and 2. Here 2 and 1. That is okay. Loopback numbers are okay. Okay, it says peer in wrong AS. 2.2.2.2 is in wrong AS. We have configured here 2 only.
Sir, I think router BGP 2, neighbor 1.1.1.1, remote AS 11, I think it is.
Oh, is it? Yes, you're right.
Yeah.
Typo it is. Looks very similar. Copy. And I'll say here, this is on R1, right? On here, we have to do it. And here we have to change it to go back 1. Okay, remote AS, sorry. 1 only. Then with the eBGP multi-hop 2 also, it will come up, not a problem. We don't require 3, we can make it 2. And here also I can make it 2. See, neighborship is up. So even if the multi-hop I have set it to 2, that will be fine. So you can see do show run 5 section BGP. This is the BGP configuration. We have set the eBGP multi-hop to 2. And now if we check, do show IP BGP summary. So neighborship state is not idle. So this is how it is. Okay. So this is done. So this thing is clear that what you have to do on in case of iBGP. So in iBGP, your update source loopback 0 is more than sufficient. And in eBGP, we have to use one extra command, that is eBGP multi-hop. Clear? So these are the keep alive messages. And this is the type. And here, you see, TTL value we set it to 2. So here it is the 2. By default, it is 1 only. Okay. All right. Close this, quit. Then after this, we can go with the BGP authentication. That how do you configure authentication in BGP? Okay, so configuring authentication in BGP is comparatively simpler than other protocols. Okay, so if we talk about BGP authentication, right? So BGP supports only MD5 authentication. Okay. So only MD5 authentication is supported. How do you configure it? You don't have very fancy ways to configure. You just say router BGP ASN. So whether it is iBGP or eBGP, you just say neighbor IP. Okay. Then you say password and whatever the password you want to set. This is very simple. This is only your authentication in BGP. Okay. So if I go to the lab here, let's say right now we have R1, R2 configured. So let's configure authentication also. So if I say neighbor 2.2.2.2, I can say password Cisco. So neighborship should go down because authentication will mismatch. Okay. So it will take time. I can clear the process, do clear IP BGP start. So this will bring down the neighborship and the neighborship will not come up now. Why? Because password has been configured. Okay. So if I check the neighborship right now, do you see no message digest from 2.2.2.2? So bad authentication. So this kind of logs we are getting. Now if I go on R2 and if I configure the same thing here, that 1.1.1.1 password Cisco. Now this will receive the message digest and neighborship will come up. Do show IP BGP summary. So you can see earlier it was in idle right now. So wait for it, it will come up. Okay. No message digest. And you see neighborship is up. Neighborship is up. Okay, if the authentication is same, then we will get the neighborship. This is clear. Authentication, simple.
Yes, sir.
Okay. So now what? There is a concept in BGP that is known as route reflector. Okay. iBGP route reflector. This is a concept in BGP. Now, what is the route reflector concept? So first of all, we will understand, what is the, like, why do we need the route reflector? There are two concepts. One is the route reflector and another one is the BGP confederation. These are the two, you can say, configurations. So why we require these configurations? Earlier, we talked about, the iBGP loop prevention mechanism. Okay. This concept here that we know that, okay, if a router receives a route from the iBGP peer, it will not advertise it to another iBGP peer. Correct. So right now, what is happening that, okay, what I can do is I can break this split horizon. So I can configure a full mesh neighborship between R1 and R3. right? We can use a static route or we can use OSPF EIGRP to do that. Correct? But here only 3 routers are there. What if my one router, because on the internet, we know the routers, how they are connected. One router is connected with multiple routers. Okay. Within, let's say, within one ASN, I can have multiple routers. Let's say I can have 1, then I can have, let's say, 2, then I can have 3, 4. Like this, I can have multiple routers. Okay. Might be these are connected like this. So now what will happen? Okay. Now what is going to happen? Let's say this is R1. This is R2. This is R3. This is R4. This is R5. Now, if this kind of multiple routers are there and everybody belongs to the same ASN, in that case, what will happen? When this guy will advertise something here, so R1 will not advertise here or here or here, because this is coming from IBGP. I will not give it to any other IBGPs. Fine. Same way, if R3 is sending something, so I will not give it to R2, R4, or R5. If R4 is sending something, I'll not give it to R2, R3, or R5. If R5 is sending something, I'll not give it to R2, R3, and R4 because of IBGP split horizon, right? And to avoid that IBGP split horizon, what we generally do is we configure full neighborships. That means one neighborship is here between, like if we talk about the neighborships, so one full neighborship will be there between R1 this, one will be here, one will be here, one will be here. These are the full neighborships. But to break the IBGP split horizon, we will have to configure one neighborship between R2, R3, one neighborship between here and here, and another neighborship here. This also I have to do. Then I need one full neighborship between R3, R4 also, one full neighborship between R4, R5 also, one full neighborship between R3 and R5 also. This is how I'll be able to break the complete IBGP split horizon. But don't you think I will have to configure a lot of full mesh neighborships here? Yes or no?
Yes.
And if I want to calculate what is the total number of full mesh adjacencies required here, so we have the formula, right? We have the formula. What is the formula? We have like n multiply n minus 1.
Minus 1 by 2.
Correct. Right? Divide by 2. So according to this calculation, if we see, this is what? Number of full mesh adjacencies. Number of full mesh adjacencies required. So this is how you calculate. So 5 I have. So 5 4s are 20. That means almost 10 neighborships I require here. Okay. I require almost 10 neighborships. So this is not a good idea, right? Configuring. And right now, again, I have considered only 5. What if there are more? So in this kind of scenarios, we use what? The route reflector. In this kind of scenarios, we use route reflectors. Is it clear? So let me do one thing. This route reflector, let's bring it here. And let's bring this one here. This one we can say it's done. To break high BGP split horizon, we used full mesh adjacencies. Okay. But this is impractical for large networks. Okay. This is impractical for large network, as a use number of full adjacencies will be required. Okay. This is clear. Then to get rid of, or you can say to reduce, or reduce the number of full mesh adjacencies required. Kind of DR-BDR concept only it is. Full mesh adjacencies required. To get rid of or reduce the full number of full mesh adjacencies required, we use two methods. What are those? Number one, route reflector. Number two, we use BGP confederation. These are the two methods we can use. One is the route reflector, another one is the BGP confederation. These are the two methods. So first of all, we will understand the route reflector. Okay. So in route reflector, what is going to happen? In route reflector, one router will be the route reflector server. In short, we will call it as a RRS, and others will be route reflector clients. Okay, which is RRC. So one of the router will be route reflector server and others will be route reflector client. Okay. Now what is going to happen? Now here the route reflector clients will have full adjacency. If you compare it with DR-BDR, right, it will be easy to understand. Like route reflector server is what? Kind of DR, and others are what? DR others. So the route reflector clients will have full adjacency with the, or you can say only with the route reflector server. So they will have full adjacency only with the route reflector server. Okay. A route reflector client will not have full adjacency with other route reflector client. Okay. So what will happen? So the route reflector client, okay, that is the RRC, will just update whatever the updates are there, right? If any new update is there, so they will update to the route reflector server, and then the route reflector server will update rest of the RRCs. Okay, same like the DR other will send update to DR and DR will inform everybody else. Here the route reflector client will send the update to route reflector server and the server will send to everybody else. Okay. This is clear. Now we can have three rules. Okay, here we can have three rules. Number one is in a route reflector concept, we can have three roles for the routers. Number one, route reflector server. Okay. Number two, a route reflector client. Number three, non-client. That means this guy is neither the route reflector server nor the route reflector client. So that guy is non-client. Okay. So if we talk about the configurational part, right? If we talk about the configurations, so on the route reflector server, on route reflector server, okay. What you will do is you will say router BGP ASN. Okay. Then we will say that neighbor, the neighbor IP, remote AS. So basically this neighbor is what? This is your, you can say, route reflector client. Okay. So you can give the neighbor IP, remote AS and ASN. And same thing will be for your non-client also. If you have a non-client, in that case for non-client also, you can give the same thing. Okay. That neighbor and let's say this is the non-client IP. Command is same only, nothing changed. Remote AS and you'll give the ASN. But the route reflector client, right? I have to mention that, okay, this guy is the route reflector client. So how I will mention? I will mention it using neighbor route reflector client IP, and we have to say route reflector client. Okay. This is the configuration you require on the route reflector server. That whatever the clients you want to make, so for them, only for the clients, you will use this extra command, route reflector client. And if it is non-client, then just like a normal configuration only, nothing change. Okay. And if we talk about the configurations on, on RRC and non-client, what is the configuration you are going to do? So there, the configuration will be as it is, no changes. Okay. This extra comments will be on the only on the server. On the clients or non-clients, no configuration change. Okay. So what you will say? You will say router BGP and ASN. Then you will say neighbor IP. That is basically route reflector server IP, remote AS, and ASN. This is only the configuration. There is no special configuration for the clients or non-clients. Is it clear? Now, let's see. Okay, if we take a look. Okay, before going to the configuration, let's talk about the peerings also. So if we talk about the peering, that means with whom they can form the adjacencies. Okay. So if I say route reflector peerings, or you can talk about adjacencies. So number one, they can have a eBGP neighbor. Okay. They can have a eBGP neighbor. So eBGP neighbor, you do not require any special command. Okay. Same like this. Neighbor, neighbor IP, remote AS and ASN. That is the configuration only. Okay. So you can say no. So in this case, my configuration is as usual. No extra comments required. Okay. As usual, eBGP configuration only. That means you just say neighbor, neighbor IP, remote AS and ASN. That is the only configuration you require. Clear? So this is one kind of neighbor it can have. Another, it can have a client as a neighbor. That means maybe an iBGP client. That means a route reflector client. That is the second possibility we have. So second pairing can be, you can have iBGP client neighbor. So if you have a iBGP client neighbor, right? In that case, we require only one extra command on the route reflector server. This command, right? This is the command. So here we require one extra command on route reflector server. Okay. Which command? That I will paste. What is the extra command? So that command I'll paste here. I'll leave some space and no extra command required on client. The configuration will be as usual. Okay. The configuration will be as usual. So this command is the extra command that you need. Okay. And if a non-client is a neighbor, in that case, again, no special configurations required. Non-client neighbor. Okay. And again, this will be in the same iBGP only. Because if it is in the different AS, it will become eBGP. So iBGP non-client. So in this case, no special configuration required on RRS or non-client. The configuration is as usual iBGP configuration. Okay. There is no extra commands required. Okay, these are the three types of pairings that are possible. Okay. This is clear. Now let's bring up the lab for route reflector. More actions. Stop all nodes. Close the lab. BGP route reflector. Open it. Okay. So here, this will be eBGP peer, and these all are iBGP peers. Okay. So overall, I have one route reflector server. I have two clients, two non-clients. Okay. And then I have one eBGP peer. That means there are some rules that we have to see. So first of all, we'll discuss the rules. Then we will see the labs. Okay. So let these routers start. Meanwhile, let's go through the rules. So if we talk about the route reflector rules, if we talk about the route reflector rules, okay. So there are three rules. Okay, not many rules are there. There are three rules. There are three rules in route reflector. Okay. What are the three rules? The rule number one. Okay. The rule number one says rule one. So rule one says that whenever an IBGP peer or IBGP non-client, okay, updates the route reflector server, then the route reflector server will send the update to route reflector client, but not to the non-client. It will not exchange the update to the non-client. Okay. If a non-client is sending an update, so that update will not be sent to another non-client. That is the first rule. To another non-client. This is the first rule. Okay. So if you want to graphically understand it, let's consider you have one IBGP non-client. Okay. Then you have a route reflector server, and you have again a route reflector client. And other than client, we do have one again non-client. Okay. Now understand this thing. So if, first of all, let's make the connections. Okay, consider this is the scenario. So if this guy is sending an update, if this guy is updating route reflector server, so this update will be sent to the route reflector client, but it will not be sent to the non-client. That means simply understand non-client update will not go to another non-client. This is not going to go. This is the first rule, that a non-client update will not go to the non-client. Okay, this is the rule number one. What is the rule number two? The rule number two says if we talk about rule two, if an route reflector client sends an update to a route reflector server, this the route reflector server will send the update to route reflector client, to another route reflector client, and also to non-clients. Okay. This is clear. That means if a route reflector client is sending something, that will go to everybody. Okay. So same again, graphically, if you want to understand. So we have a route reflector client, we have route reflector server, and we have another route reflector client, and we have a non-client also. Okay. And they are connected. So if this guy is sending the update to route reflector server, the route reflector server is going to send it here as well as send it here. Both the places it's going to send. Then rule number 3. If we talk about rule number 3, if an eBGP peer sends an update, the route reflector client, update to the route reflector server, then the route reflector server will send the update to RRC and non-client. That means again, this also will go to everybody. Okay. Let's copy this, paste it. Only one change, that this is eBGP. So if a eBGP peer is sending anything to the route reflector server, the route reflector server will send the update both to client and non-client. Okay. But in route reflector, what will happen? Whatever the update is there from eBGP neighbors, that will not be selected as the best route. Okay. Whatever the update is there from your eBGP, that means whatever the update is coming from eBGP, so that update will not be selected as the best route. Why? Because when the eBGP peer will update, IBGP neighbor, then what will do? IBGP will not update the next hop. So that thing I will explain when when we are doing the eBGP practical. First, let's confirm these two. Okay. First, let's confirm these two things, these two rules. Then the third rule I will explain. And in the third rule, we will see that there is some problem. Okay. And due to that, we will use the extra command. Okay. There will be one extra command required in the third case. So first, let's verify these two. Let's go to the lab. Okay, so first we will verify that what happens when a non-client updates it, and then we will verify that what happens when a client updates it. So we have overall 4 to 6 routers. So first one, let's say I want to configure for a route reflector server. Okay. So the route reflector server is having the 0x0 interface as 16.1. Okay, then loopback is not there, not required. A route is not required. Then we have interfaces. How many? 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, so we Z 0x0 is there. Z 0x1. We have 12.1. Z 0x2. So we have 13.1. Z 0x3. We have 14.1. Z 0x4. We have 15.1. Okay. And the ASN here, we are using 1, 2, 3, 4, 5. Okay, so neighbors I will give. So 16.6, first one. 192.168, 16.6, and the remote ASN is 6. Okay, and right now we are not forming the neighborship using loopbacks, so no need of this comment. Then we have 4 more neighbors. 1, 2, 3, 4. Okay, so number one is, first of all of them are having ASN 1, 2, 3, 4, 5. So let me copy paste this. Okay, one is 15.6, then we have 12.2, then we have 13.3, 14.4, and we have 15.5. Okay. All right. This is done. Okay. And these two are clients. Okay. 12.2 and 13.3 are clients. So for them, I will use the command route reflector client. This is for 12.2. I'll say this is what? Route reflector client. And same thing for 13.3 also. Or I can copy this only. This will be 13.3. Okay, so I have configured on the route reflector server that these two are clients. And for these two and this one, we don't require any special commands. Okay, so this is the route reflector server configuration done. Right? Now, let's say I want to configure RRC1. 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 So Z0 by 0 is 12.2. That is okay. Loopback is not there, not required this one. And also we don't require this one. Then ASN is 1, 2, 3, 4, 5. Okay. Then neighbor is route reflector server only. So 192.168, 12.1. And this will be remote AS 1, 2, 3, 4, 5. Update source we don't require. Correct? Okay, so this is the configuration for RRC1. Then let's copy this. This is the RRC2. This is the RRC2. RRC2. This is 13.3. Then we have NC1 and NC2. So, okay. This will be, neighbor will be 13.1. Remaining everything is okay. Then this will be non-client. Non-client 1. This is the non-client 1. This will be 14.4. And this will be 14.1. The rest of everything is good. Then NC2. This is the non-client 2. And this will be 15.5. And this will be 15.1. Okay. Now, this is done. Then we need one for eBGP. This is the eBGP neighbor. And this will be having 16.6. 16.6. This will be neighbor 16.1. And self ASN will be 6 here. And this ASN will be 1, 2, 3, 4, 5. And here remote ASN is 6. Okay. All the configurations are done. Now let's take an access. So first of all, route reflector server. Open. Okay, say no. RRC1, RRC2, NC1, NC2, and eBGP. Okay, now what? Let's say no, 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 no. Now, route reflector server. Copy. 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 Okay. So done. Let's wait for the neighborships to come up. So the route reflector server should have, the neighborship with everybody. Okay. Now, let's talk about the first rule. So if we check the first rule says when a non-client is going to update the RRS, then the RRS will not send the update to, it will send the update to RRC, but it will not send it to non-client. Non-client update will not go to non-client. Okay, fine. So we have a non-client here. We can see that we have 14.4 also and 15.5 also. So on R5, what I'm going to do is I'm going to, advertise an update. So this is the non-client 2. Here, I'll say interface loopback 1, and I'll say IP address 5.5.5.5 255.255.255.0. Okay, and then I'll say router BGP 12345. Okay, and so far I haven't advertised. So you can see like on the non-client one, do show IP BGP. No route information. Here, do show IP BGP. No information. If I check here, do show IP BGP. No information. And definitely here also, do show IP BGP. Okay. So now let's go here. I'll advertise that. I'll say network 5.5.5.0 mask and 255.255.255.0. Done. Once I say this, now let's check on route reflector server first. Do show IP BGP. So I can see 5.5.5.0 came onto the route reflector server. So is it going to the route reflector clients? So you can see, yes, it is going to the route reflector clients. Okay, is it going to another non-client? No, this is not going to non-client. This is clear, the first rule. So a non-client update will not be sent to a non-client. Clear? Now, what about eBGP? So do show IP BGP. So yes, it will go to eBGP. But simple answer is non-client update will not go to non-client. Okay. And everybody else will have the update. All right. Now, what if a route reflector client is updating? So if a client is updating, that update will go to the eBGP also, that will go to the non-client also. Okay. And also it will go to other clients. So it will go to client, non-client, and eBGP everywhere. So we can see that this is, let's say, R1, which is a client. So here I'll say interface loopback 1. Okay. IP address 1.1.1.0 255.255, sorry, 0. Oh, sorry. This will be 1.1.1.1. Then if I say router BGP and 1, 2, 3, 4, 5. And if I say network 1.1.1.0 mask 255.255.255.0. So if I say this, now this update will go to the router reflector server. Okay, you can see, and this update will go everywhere. Okay, let's say if I check on RRC2. So yes, the update for 1.1 is coming here. What about the non-clients? You can see the update is coming here also. Sorry. Do show IP BGP. So this is coming here. Okay. And here also we can verify. So this is how it is. Second rule verified. Now rule number 3 says that when eBGP updates, then what happens? That will also go to the route reflector server as well as route reflector client. Okay. So let's go to the eBGP, which is 6. So interface loopback 1, IP address 6.6.6.6 255.255.255.0. Okay. Then router BGP 6, and I'll say network 6.6.6.6 mask 255.255.255.255. So this will go to everybody. Okay. It will, you can check like on the route reflector server. Wait for it. The BGP process number here was 6 only, right? Yeah, that is fine. And do show IP BGP summary. So this is clear. AS number is 6. Everything is good. ASN is 6. 1, 2, 3, 4, 5, and here also 6. Everything looks good. Do show IP BGP. One more time. Do show IP BGP. Okay, not here. What about do show IP BGP? There it is. Why this update is not coming? Okay, let me go here. Do clear IP BGP star. Neighborships came up. All the neighborships are up.
Do show IP BGP. Do show IP route. Why I'm not getting the 6.6? Do show run pipe section BGP. Network we have advertised. Do show interface. Running interface loopback 1. Okay, the subnet mask is problem. Interface loopback 1. IP address 6.6.6.6 255.255.255.255. Now it should be advertised here. Do show IP BGP. So we can see that this came in. Okay, and this will go to everybody. Do show IP BGP. Here also you can check. Do show IP BGP. Everywhere you can see. Do show IP BGP. Do show IP BGP. Okay. And here also you can see do show IP BGP. Okay. So everywhere we can see like the 6.6 update is there. Correct. But when I try to ping, right, let me try to communicate with this. Do ping and 6.6.6.6. What do I have? I see something that there is no communication. There is no communication. What is the problem? The problem is, see, when this guy is updating a route reflector server, so in here, the next stop is 16.6. And what route reflector server is doing? It is keeping the next stop as same and then advertising. So you see here, these route reflector clients, they are also getting next stop as 16.6. Now these guys, they don't know how to reach 16.6. Okay. These guys, they don't know how to reach 16.6. So what we have to do, we have to use one extra command on the IBGP neighbor. Okay. That means this guy. So we have to use one extra command. What we have to say? We have to say next stop self. So that this guy will do what? Before advertising the routes to these people, before advertising the eBGP routes to these people, it will do what? It will change the next stop to these relevant values like 12.1, 13.1, 14.1, 15.1, like this. So what we'll have to do? We have to do one extra thing here. That is, let's say this is your neighbor. Control C this. And let's say I'll just paste it here. And I'll say next hop self. That means this route reflector server has to say everybody that I am your next hop. So this is for 12.2 and for remaining 3 others also. So another one is for 13.3 neighbor also, for 14.4 neighbor also, and for 15.5 neighbor also. Okay, now check. Copy, go to the route reflector server and paste these comments. Now what will happen? When these guys, they will receive the routes. So they will have this next stop updated. So to update this, let me do clear IPBGP star stop. Check again. Do you see? On this guy, it is 12.1. And here, if you check, so do show IPBGP. Now this is 13.1. Here it is 14.1. And here it is 15.1. And now we will be able to ping. If I say do ping, sorry, not this, 6.6. So now I will have the communication.
Okay. From here, the packets are going. This guy doesn't know about 12.2. Okay, still this guy doesn't know about 12.2. So we don't have a route. We need to provide reachability. Then only the communication will be there. Okay, but you see now, earlier this was not getting selected as a best route, and now this has been selected as a best route as soon as we gave the next hop self, because the next hop changed from 16.6 to 12.1. Okay, because BGP will always require connectivity. BGP will always require reachability to have communication. So right now we don't have, because any neighborship is not there, direct neighborship is not there here. Okay, this is clear about the next of self comment. So what do you say that in route reflector, the update from an eBGP neighbor is not selected as the best route, because when an eBGP neighbor update an iBGP peer, the iBGP peer will not update or change the next hop to itself when forwarding the update to other iBGP peers. Okay. So to change the next hop before forwarding the updates to other iBGP peers, we have to use one extra comment on the iBGP neighbor that is connected to the eBGP peer. That means we have to configure the command on which router? The router that is connected to the eBGP. And in our current case, who is connected to the eBGP? The route reflector server. So there we have to give this command neighbor IP, and we have to say next hop self. Next hop self. This is the command that we have to use. Clear? Yes or no?
Yes, sir. Sir, in that case, like that eBGP and RRC to communicate, we have to give static
Yeah.
routes.
Static route or dynamic routing we have to use.
Yes, sir.
Yeah. Okay. This is clear.
Yes, sir.
All right. Because the eBGP doesn't know, right? The eBGP doesn't know how to communicate with the RRC network. That is the reason. So for like 12.0, we have to give a route, then they will be able to communicate.
Yes.
All right. Shall we start the next concept? Is everybody okay? Or enough?
Sir, it's enough, sir. So many things.
So what do people say? If you think it's enough, then we can stop, no problem. Yes. Give me a yes or no. Enough, or we can continue.
It's enough, sir.
Enough? Okay. All right, then. We can stop here. Okay. All right, guys, then. That's it for the day. I'll see you guys on Monday. So, how we will be going? Just let me stop the recording.